Okay, so what we had done was to say, you could use the tables, you can do that, but Blinky is so much faster at finding the answers for us, so let's just look at problem number 1. And the top one we see is all ready to go into the calculator there. But the bottom one, you're gonna need some help. So the top one we can just plug right in. What do we need to do to the bottom one so we can put it in the calculator? Thank you. I thought we were going to stare at it a little longer. So here are the 2 equations that we need to put into the calculator and let Blinky find the intersection for us. So let's see, y equals, I've got x minus 2. Everybody finding the x okay? Remember that's up there by that green alpha key. And then make sure you use negative x, not subtraction x. Negative is down by the decimal button, so negative x plus 10. Well, let's just try and zoom 6. Let's see if on that negative 10 to 10 window Blinky can get us a good idea. Ah, obvious intersection there. Now do you remember where to go? How do we get Blinky? Second trace. Which one? 5. What's up on? Ooh. Clear it out for you. Cut it off. There we go.
Oh.
Hold on. For the fancy stuff. We need the fancy stuff. All right. Yep. Oh, Blinky's just asking you, is this the first line? So you just need to make that. Okay. Alrighty, so Blinky is telling us the intersection is at 6, 4. Something not going right there, Zach?
He's only did it on one line. That's X.
Yeah, I'm going to reset it. So now just 6. Well, I'll see back to that negative 10 to 10. X minus 2, negative x plus 10. Zoom 6. And get back to that nice window right there. Everybody else, things going okay? All right, so we would write down the ordered pair 6, 4. Just getting Blinky to do his job. And again, you could do the table. I mean, if you were looking at that and something, you're taking the quiz and you're like, oh my gosh, this is not working. My Zoom fit is not showing me what I need. Just go to the table and notice, hey, y sub 1 and y sub 2 are the same. That's 6, 4. You know, and you can use the table as well. Oh, wow, jump right into the word problems, huh? Let's go down there. Let's see. 13, I think, is the more difficult of those 2. It says, your school sells tickets for its winter concert. Student tickets are $5 and adult tickets are $10. If your school sells 85 tickets and makes $600, how much of each ticket did they sell? Find me a total. 600 bucks? So how are we making that $600? Find me some other money stuff. $5 for student tickets. What else? 10 for adult tickets. So I'll have X be student tickets and Y be adult. adult tickets. There's our first total. We know we need 2. Where's the other one? 85 tickets. Anywhere in there, does it say we have to sell twice as many student tickets as adult tickets, or there were 800 more adult tickets sold than student tickets, anything like that? Nope. X plus Y equals 85. There it is. Now, this side is supposed to be about substitution. So, we could certainly check this with the graphing calculator when we're done, but boy, is this ever set up nice for substitution, because look at our little X and Y down there all by itself. I think I'd like to be able to plug something into that. I like multiplying by 10 better than 5. They're both kind of nice numbers, but let's go ahead and subtract X from both sides. And then substitute this in for Y. And see what we get. So 5x plus 10 times our little negative x plus 85 needs to come up to 600. All right, so that'll be 5x minus 10x plus 850 equals 600. What should we do next? Yeah, you are. All right, so we've got a negative 5x plus 850 equals 600. Subtract the 850 from both sides. Negative 5x equals a negative 250. Now let's divide. What did we just find? Yeah, the student tickets. X was the student tickets. So 50 student tickets. Is that all we were supposed to find? No, we're supposed to find the adults too. So if we sold 50 student tickets, how many adult tickets were there? 35, right? Because we can take that 50 and we can put it right back up in here, or we can just say to ourselves, well, they said they sold 85 tickets. So 85 minus 50 is 35. Again, we already solved the green one here for Y. We definitely could solve the blue one at the top for Y and then put it into the calculator, but we'd have to change our window because, I mean, our numbers are big in this one. So could be solved with the calculator just to double check that one. Alrighty. Without graphing, classify each system as independent, dependent, or inconsistent. This is exactly what Alex was asking about earlier. So let's just look at number 16. Now I like this one because it's already set up for substitution. You know, it says y equals this. Well, hey, then let's put that in for y and let's see what we get. So x plus 2x minus 3 equals 3. Just substituting this right in for y. All right, so this will give me x plus 2x minus 3 equals 3 because the parentheses aren't really doing anything. And that's going to be 3x minus 3 equals 3. Okay, I'll add 3 to both sides. So 3x equals 6. Divide by 3. And x equals 2. Now, they didn't ask me what the answer was. They said, is this going to be independent, dependent, or inconsistent? Am I getting an answer here? Sure I am. I got x equals 2. I'll plug that back in and I'll get another one. That's independent. That's one answer. So this is independent. remember, what we're watching for to happen is if they're both the exact same line, then what we're going to get is like 0 equals 0 when we get done. That'll always be true, and that's dependent. If they have the same slope, we might get something like this, 4 equals 9, and that's going to be inconsistent. That means there isn't a solution because 4 does not equal 9. Well, that's not going to work. So let's go ahead to 17 then. This one again too, this is set up perfectly for substitution. If y equals this, well then let's replace it. So 2x plus negative 2x minus 1 equals 3. So if y equals negative 2x minus 1, I ought to be able to put that in there for y. So that'll be 2x minus 2x minus 1 equals 3. And this is where we realize, okay, something's going weird right away because these are gone. What does that mean? No solutions, but they didn't ask us if it's supposed to be no solutions. What does that mean? Inconsistent. Yeah, we don't like having to write down that we cannot find an answer. We can't. In fact, no, I don't care about. That's why there's no solution and it's inconsistent. Okay, anything else on that side? Somebody have one? If they're thinking we should do this one together on that side. Flip it over. Well, I'll let you pick. 1 through 6 say solved by substitution. That was hard to get out on this Monday morning. So pick one. Which one looks like something you want to do together? Number 4. 4 it is. Alrighty, gonna do this one by substitution. Seems y is the logical little pick there to get by itself. So let's go ahead and subtract 2x from both sides. And we get that little mess right there. And we say to ourselves, self, I haven't even used that first equation yet. Nope. So we need to take this and put it right in here. And hopefully while you're writing it down, you're saying to yourself, ooh, I'm going to have to be careful. There's a lot of negatives in this bucket. Yeah, there's a lot of negatives here. So it'll be 6x plus 6x, because we've got a negative times a negative, plus 3 equals negative 33. So be really careful with your negatives. And that's going to be 12x plus 3 equals negative 33. And then we'll subtract 3 from both sides. So 12x equals negative 36. And we should be feeling like, yes, things are going nicely here, because if I divide by 12, I get x equals negative 3. Cool. But I'm not done yet, am I? Do you see a nice spot to put that negative 3? Get the line? Yeah, green circle up there. Let's put it in there. So y equals negative 2 times our nice little negative 3 minus 1. Well, that's going to be 6 minus 1, which is 5. Almost done. What's left? Write it as an ordered pair. Negative 3, 5, x, comma, y. And we've got it. That was a good one. How you feeling about number 6? Everybody gonna be okay with number 6? All right, so let's look at 6. First off, I'd look at that and say, hey, I can divide both of those by 4. And then the other equation is all set and ready for substitution. I mean, if we're saying x equals 2y, that means wherever we see an x, we're going to plop a 2y in there instead. So 2 times our little 2y plus 5y equals 27. That will give us 4y plus 5y equals 27. And that is 9y. And again, we get the feeling like, yes, I did something right. Because I got y equals 3. Where's a good place to put that? Yeah, 2y. Right back up there. So sometimes when they actually were trying to help you out and make it an easier problem, it can really be confusing. It's like, okay, they're missing something. What on earth did they do here? They're messing with my head. And that's what they were doing with that one. Just need to make it a little easier. Oh, let's go down to elimination. Pick one from 11 through 16. Which one? 13. 13 it is. Oh, I would love to do this problem by substitution, but they said elimination. So with the elimination, what we have to do is we have to get either the x's or y's to be opposites, so that when we add them together, they'll drop out. Well, if we just multiply the red one up there by -1, that'll happen. But you have to multiply everything by the -1. Whatever we do to the equation, we have to do to everything in the equation. So I'm going to add my little black and green ones together and see what I get. Well, x's are going to be gone. That's cool. 3y minus y is 2y, and 11 minus 7 is 4, and oh, so nice, y is 2. And you want to go back to red or black? Plug that in. The red one's pretty easy, isn't it? It says that x plus y has to add up to 7. So if we put x plus 2 equals 7, it's kind of like, well, we don't even need to really think about that. That's going to be 5. So there's a nice basic example of elimination where we just have to multiply by a -1 and things drop out. All right. Anything else from that back page? Okay. Because the rest of this is going to be your homework. Now, I'm going to phrase the question a little differently and see if I get a different answer. If these are the only things we're doing before the quiz, do you have any you'd like to look at together? 10 on, suppose you bought 8 oranges. Okay. Suppose you bought 8 oranges and 1 grapefruit for a total of $4.60. Later that day, you bought 6 oranges and 3 grapefruit for a total of $4.80. What's the price of each type of fruit? Give me a total. All right, $4.60. How'd you get that total? What'd you buy? Ooh, oranges and grapefruit. I'm not going to use O for a variable. Well, let's just have X be the oranges and Y be the grapefruit. Grapefruit. That's a fruit that's supposed to be really, really good for you. It's not a very sweet one unless you really spend a lot of money. So 8 oranges plus 1 grapefruit. Cool. 8x plus y equals 460. You got another total in there somewhere? $4.80. Okay, how'd you spend your 480? 6 oranges and 3 grapefruits. Now it doesn't say we have to use one way or another here, but substitution would definitely be the easiest way for this one, because look at this little y. It's practically screaming, solve for me, solve for me. So we'll subtract 8x from all sides. So we get negative 8x plus 460. We need to plug that into our green one for y. And yeah, we'll have some decimals with this one, but it's about money, so that's going to happen. So we distribute the 3, and we get 6x minus 24x plus 460 times 3. Well, I'll do it up here. Usually with money, people can do those a little bit faster and get the 1380 without having prep. But a lot of people don't like working with decimals, so that'll work. We'll subtract the x's first. So 6 minus 24, that makes us squirm a little bit because we get a negative, and this is actually a word problem. But then in the next step, we see, oh, everything's okay. We're going to have a negative on the other side, too. So we divide. And we get 50 cents. What's 50 cents? An orange. 50 cents per orange. Which one do you like better? The blue one or the green one? Plug them back in. Blue? Yeah, might as well go back over here. In fact, y equals negative 8x plus 460. And we'll plug in our little 50-cent oranges. So you've got a negative $4 plus $4.60. So it's 50 cents per orange and what? 60 cents per grapefruit. Okay, flip her over front and back. Maybe one more. Or what time is it? Regular bell station. Oh, no, you better not do one more. I want to make sure you have time to do your little school duties. So, calculator, pencil, Chromebook, and I will open that up for you. My Schoology.